Hi everyone, in this video I'm going to show you how to perform docking of a ligand to a macromolecule using AutoDock FR, and later we will visualize the result. AutoDock FR was made as an improvement upon AutoDock 4 and AutoDock Vena, and it's still relatively new. Its strength lies in its ability to more properly account for residual flexibility in the receptor. So first what you want to do is to grab the files for both the macromolecule and the ligand. For this demonstration I'm going to use 5 FRI as the protein, that's going to be the macromolecule. Download files, PDB format. Save it. And for the ligand, it's going to be farnesylferrol C. So we're going to dock this molecule to 5 FRI. So I look for the 3D conformer, download SDF. Save it, and make sure you have Discovery Studio visualizer installed, and we're going to use it to process both of the files first. The first one I'm going to process is the macromolecule, so open this. And we want to remove all of the ligands that are currently bound to this protein. So I go to Scripts, Selection, select ligands, and delete them all. Save as, save as PDB. Give it the name of receptor, and close it. Now I want to open it again, actually, because I want to keep this for now. The position of this ligand, which is currently bound in this file, crystal structure to the protein, because this is our reference ligand, to say. The docking is going to be performed in the site where this ligand binds to the protein. So we want to keep this and save it alone as a reference. What you do is edit, invert selection, and delete. Now you can save it. Close. And now we want to process the ligand file. Earlier we got this in the format of SDF. We need PDB for now. See, open it with this, and well, actually we just want to simply save it as PDB. So I save it as a PDB file. The next step is we want to prepare the ligand and the macromolecule both to be used in AutoDock FR. AutoDock FR requires both of the files in the format of PDBQT. Before we begin to process our protein and ligand files, we will first move them to a file. Here, I've set this here. It is optional and you can set it anywhere you want actually. So I'm just going to copy them all here, and what this does is basically to act as the working directory for AutoDock tools. So when you open AutoDock tools, you are able to set working directory by going to File, Preferences, and Set. This is the working directory where the files are going to, you put all the files in to make work that little bit easier. So first we want to process the macromolecule. Right click, read molecule, and open the receptor. Okay, and the way you process the receptor is by edit, delete water, edit, hydrogens, add, okay, edit, hydrogens, merge nonpolar, edit, charges, add Coleman charges. Okay, at this stage you are allowed to save the protein now. As by doing this, create macromolecule, choose receptor. Okay, and save. This is a PDBQT file. Another one, we want to process the ligands now into PDBQT. But to open the ligand, you do not open it from here, but you need to do this: ligand, input open, and we choose the ligand file. Here it is. Okay, and just output it as PDBQT. And do so for the reference ligand also. Right, at this point we got 3 of the PDBQT files, and we can now close AutoDock Tools. Now we move to AGFR. In AGFR, you're going to be asked for a receptor file and a ligand file. First, for the receptor, you open the created PDBQT file from here, the receptor, and the ligand is the reference ligand. First, if you do not know the binding pockets, so you just simply click on Compute Pockets. Right, so it's going to tell you the possible binding sites for the ligand. There are several that has a high score, which is supposed to be a good binding pocket. But since we know that the reference ligand is here, we just need this one. So we can deselect this number 2. At this point, you want to change the ligand. Change the ligand into your actual ligand, right? So that now you know this. The binding site is here. Give it a second. You want to choose number 1 only, and for now, select this to set the grid box smaller to only accommodate the space necessary to fit all points in the binding pockets. Now, this grid box is where all of the computations will be performed when you do the docking. And there is an optional step here actually, which is to set flexible residues, which can be done using this. And you have to manually select it. Or alternatively, if you still have that reference ligand before, if you look at this residues within of ligand, you can just choose it. It will set those residues as flexible. But in this case, we're not going to use any flexible residue. So after you've selected this binding site, and I want to compute the maps here, so choose from legend types, generate maps. Let's browse the location. Let's first say desktop, and give it the name of maps. Okay, I'll give it some time. You can see the progress here being outputted, and when you see the line creating zip blah blah blah, it's when you know that the progress is actually completed. So give it some time. It can take a few minutes. Alright, here's the line creating zip file. So now we are done. We can close this for now. Running ADFR requires command prompt, but before doing that, I suggest you do this. Go to the directory where ADFR is installed, create a new folder here, and paste all of the files that are required for the computations into this location. So that includes the maps and the previously created PDBQT files. Now you're ready to run ADFR. Use command prompt. Move the directory here. And run ADFR by doing this. ADFR.bat. The first argument is the location of the ligand file. And the second argument is the maps that we have created before using AGFR. The third optional argument is reference. The reference is for a reference ligand. If it is the same ligand that is already bound to the protein, you can use it to guide where ADFR will perform the computations and hopefully give you a better result. But since we do not have a reference ligand, we do not use it for now. So just enter and run it. ADFR will try to find the best conformation of the ligand that is bound to the macromolecule. Give it some time. Right, so at this point the computation has been completed, and if you look at where the ADFR is located, you will see this new file that is created, which is the ligand in its bound conformation. Now, the next step to do is we want to view the ligand and the macromolecule and how they bind, how they interact. To do that, we need to first create two PDB files from the ligand and the macromolecule. We can close the command prompt for now, and we will use OpenBubble to create the PDB files. So before opening OpenBubble, let's say we copy them all to one location. So OpenBubble. We now want to convert basically from PDBQT to PDB. So the input file will be the ligand. The output file is convert. We will create a new file here, and then the macromolecule. Convert. Right, now you can close this. Now you have these two new files, the receptor and the ligand. You will combine those two using Discovery Studio Visualizer. Open the two files. And just copy the ligand to the receptor. Now open view hierarchy, and you will see this. There are two instances here. You want to move this here, so as to create another chain. Feel free to rename it for now. Let's say this is ligand, and this is phanecyferol C. And you can save this. File, save as. Let's save it in desktop as PDB file. Close it. Now, to view the interactions, we will use Lick+. Do so by File, Open, PDB file, and the previously created PDB file here. Okay, here it is. Now run. And here, in LickPlot, you will be displayed in 2D the interactions between the ligand and the surrounding residues. You can modify this to your liking. For example, by modifying some settings here, you can show hydrogen bonds, hydrophobic interactions, so just like this, for example. And to see it in 3-dimensional, there is this button Pymol here. Just click it, and you will see the 3D conformations here with in its bound position. So you can analyze this using the 3D conformation or as a 2D chart here. And that's basically it. So first you get the macromolecule and the ligand, and then you prepare it using AutoDock tools. You set up the grids using AGFR. You perform the docking using ADFR. You merge the files into one PDB or using DS Visualizer or any other program actually that can do that. And finally you can view the interactions using LinkPlot. I hope it's been a helpful video for you. So thanks for watching.